Okay, in section 6, we're going to look at finding the distance between a line and a point that is not on that line. In other words, the shortest distance between that point and that line is going to be the perpendicular. So we're going to have quite a few steps through this process. There are actually 4 of them that we're going to have to do. First step is to find an equation of a line through 2 points. Then you're going to have to find the equation that's perpendicular to that line. We'll have to find the intersection between both of those lines, and then we have to use the distance formula, which will give us our distance that we're looking at. Okay, so we'll go through one of these here. I'm going to go to this one. I've got all the steps written out that we'll have to do on this slide as well. So the first thing, line L contains points 1, 2, and 5, 4. That's where we're going to start. We need to write an equation of a line given the points 1, 2, and 5, 4. And I would suggest doing this in slope-intercept form. So we're first going to find slope using this formula. So we'll go 4 minus 2 over 5 minus 1, which simplifies to 2 fourths and still simplifies to 1/2. Next, we're going to use point slope because I do not know the y-intercept, and I'm going to use the point 1, 2. So we're going to use y minus y sub 1 equals m times x minus x sub 1. Plug in our stuff. Y minus 2 equals 1/2 x minus 1, and then we'll simplify it. Y minus 2 equals 1/2 x minus 1/2, and then finally we have to add 2 over. So y equals 1/2 x. I'm going to come off to the side again, negative 1/2 plus 2 over 1. I have to multiply by 2, top and bottom, get common denominators, so negative 1/2 plus 4 over 2. And then I can finally add them. So negative 1/2 plus 4/2, that is going to get me a positive 3/2. And I'm going to star that, or box it, do whatever you want, because we're going to need that equation for step 2. Step 2 says I need to find an equation that is perpendicular to L going through the point 1, 7. So I'm coming back up to the top, because that's what it tells me to do on this part right here. Construct a line perpendicular to L, the one that you just found, through the point 1, 7. Okay, so I'm going to come back down here to step 2. Well, if I want an equation perpendicular to this starred one up here, I need the perpendicular slope. Perpendicular slope to 1/2, that is negative 2. And then I want it to go through this point 1, 7. So we're going to use point slope form again. We're going to go y minus 7 equal to negative 2 times x minus 1. Simplify it into point slope or slope-intercept form. Y minus 7 equals negative 2x plus 2, and then add 7, y equals negative 2x plus 9. Again, I'm going to box this, or you star it, do whatever you like, but I need that equation for step 3 next. Step 3 is to solve system of equations. In other words, I'm looking for the point of intersection. So I'm going to rewrite my equations. Y equals negative 2x plus 9, and y equals 1/2 x plus 3/2. I want to know, where do these lines intersect? At what point? So I'll go ahead and write it like that. I'm looking for an x and I'm looking for a y. You can do this one of 2 ways, either through substitution method or the elimination method. I think I'm going to use substitution just because both of them are equal to y. I could see both ways as you would want to do elimination. That's my preferred method, but I'm just going to use substitution for now. So I'm going to set my right sides equal to each other. So I'm going to have negative 2x plus 9 equal to 1/2 x plus 3 hex. Okay, so then I am trying to solve now for x at this point. When I solve for x, then it will go in that spot on my point. So I'm going to add 2x to both sides. When I add 2x to both sides, it's going to give me 2.5x. And then I'm also going to subtract 3/2, which is the same as 1.5. So if I subtract 1.5, that will be 7.5. Again, you can do this. You could do this with decimals if you would like. I'd just be cautious on certain problems when you have to start rounding, because then it'll throw off your answers. Then I have to divide both sides by 2.5. So when I divide by 2.5 on both sides, it's going to give me an x value of 3. So now I know the x coordinate of my point. X is equal to 3. I also need to find a y value. But I know that y is equal to both of those equations. You can pick the one that you would like. I'm going to pick the one that doesn't have fractions, honestly. So I'm going to take this one, and I'm going to plug my x value of 3 into that equation. So I've got y equals -2 times 3 plus 9. When I plug that in, my y value is going to be 3. And I'm going to star that point because that's a very important point. Then the last step is to find the distance between that point and my original point, 1,7. 1,7 was not on the line earlier. So I'm going to use those 2 points to find the distance. Remember, your distance formula looks like this. X of 2 minus x of 1 squared plus y sub 2 minus y sub 1 squared. We'll go ahead, we'll plug in our information, big square root. We're going to go, I'm going to go 3 minus 1 squared plus, where did I go? I went 3 minus 1, so I have to go 3 minus 7. And then we'll simplify this. 3 minus 1 is 2, and then when I square it, that's going to give me 4, plus 3 minus 7, that's -4, and when I square it, that will get me 16, a positive 16. Remember, anytime I square a number, it's going to turn it positive. When I add those, that's going to get me 20. So my distance is the square root of 20, or if you want to write it as a decimal, you certainly may. That'll be about 4.4-ish, I think. Off the top of my head, it's going to be really close to that value. Personally, I would just leave it as the square root of 20.